Okay, so as x goes to negative infinity, where is f of x going? As x goes to positive infinity, where is f of x going? Okay, well, let's do these. So f of x equals minus 2, 1/5 to the x plus 3. And we're going to let x go to negative infinity. So I'm going to put in right here, negative infinity for x. So what does that mean? Well, do you remember what a negative power do? What is the exponent rule? So here's what they're testing here. Let me see if you know the rule. The rule, remember the two rules we have that we use most frequently for powers, for exponents. Anything to the 0 power is 1, and anything to a negative power to the denominator and then becomes positive, right? Negative powers are unhappy where they want, negative powers are unhappy where they're at in the fraction. They jump to the other side and then they're happy. Then the power becomes positive. Okay, so that means this will equal negative 2. What it'll do is it'll flip this fraction. Let's just do that. It'll flip the fraction. So that negative, excuse me, that negative will flip this fraction and then become positive. Did you track with that? The negative power flips the fraction that it's on. That's what a negative power does to anything it's on. It flips it, and then the power becomes positive after the flip. Are we good so far? So a negative power, whatever it is on, if it's on just like one number, it flips it. If it's on a whole fraction, it flips it. So what does that equal? Well, 5 over 1, that's just 5 to the infinity, positive infinity, plus 3. And well, what's that? Well, what's 5 to the infinity? What does that mean? Doesn't that mean, let me be clear here with you, doesn't that mean 5 times 5 times 5 forever, right? A power, like if I said, hey, what's 5 to the third power? Well, you know that means 5 times 5 times 5, 3 times, right? So 5 to the infinity power means multiplied infinite 5s, right? Plus 3 at the back. So what's that going to be? What's that going to equal? Well, if you take your calculator and go to 5, 5, 5, 5, 5 forever, this all right here is going to be negative infinity. Why? Because there's a negative 2 in the front. So negative 2 times infinity. In fact, I can do it more slowly if that helps. It's negative 2 times infinity plus 3, which is negative infinity, isn't it? Right? Because negative 2 times infinity is negative infinity plus 3. That's still just negative infinity. So f of x goes to negative infinity for part 1. Now, let me set that aside. And now let's do part 2 over here. Okay, so now for part 2. Now we're saying, again, f of x equals from the beginning up here, minus 2, 1/5 to the x plus 3. And now we're going to plug in infinity for x, regular infinity, positive infinity. So what are we going to get? What's f of x going to do? Minus 2, 1/5 to the infinity, regular infinity, plus 3. Well, what's that going to equal? Well, now notice this time it's a positive infinity, a normal infinity, not a negative. So it's not going to flip the fraction. So what will it do? It'll take negative 2. It'll take 1 to the infinity over 5 to the infinity. Are you tracking with me? So that infinite power means, well, in fact, maybe it'd be better. if I just did it this way. It's going to be 1/5 times 1/5. Well, here, we'll do one more. Times 1/5 forever plus 3, right? There's an infinite amount of them. 1/5 times 1/5 times 1/5. So what's that going to do? Well, I don't know if you've thought much about things like this, but this is going to be -2 times 0 plus 3. Why 0? Why do all these become forever becomes 0? Well, because it's just getting smaller and smaller forever. It's 1/5. So just imagine if you had, just think real life with me. What if you had a pie and I said, okay, I'm gonna only take 1/5 of it, right? So if it was 5 pieces like this, wait, that's 4 pieces, huh? Didn't do that too well. There we go. 5 pieces, and I'm just gonna take 1/5 of it, okay? And then for that little 1/5, I'm going to only take 1/5 of that. So 1, 2, 3, 4, 5, just 1/5 of that, which is a little, then 1/5 of that, 1/5 of that, 1/5 of that. Except pretty soon you'll have nothing if you do that forever. See how it's going forever? So if you take a fraction and multiply it by itself forever, it becomes 0. Because it's a part. A fraction is a part. 1/5 of something is a small part. Like if I had a candy bar and I say, well, I just ate a fifth of it. Or a piece of pie, and I say, I just ate a fifth of it. That's just a part of it, a small part of it, right? So if you take a pie, you take a fifth of it, and then you take a fifth of that fifth, and then a fifth of that fifth, you see what's going to happen? It's going to eventually be 0. So, and you can check it on your calculator. Take your calculator, take 1/5, and just raise it to a big power. Do that. Take 1/5 on your calculator, which is 0.2, and then just raise it to like the 100th power. You'll see that it'll be a super, super tiny number. It's basically heading towards 0. This is something you do in calculus a lot. If you're headed on to calculus in a semester, a couple semesters, it's an important idea to understand that when you take a part of a part of a part of a part forever, it heads to 0. Calculus studies the infinite a lot, doing something forever. So that becomes 0. So then what is this? This is, oops, f of x. So -2 times 0 is 0 plus 3. F of x is 3. So this goes to 3 is the answer for that part. And the other part was negative infinity. Does that make sense? I know this part's kind of probably somewhat tricky for you. But again, check it on your calculator or just think real life. If you take a fifth of a pie and then a fifth of that and then a fifth of that, pretty soon you're down to crumbs and dust. You have nothing left. It heads, and you're doing it forever. So if you take a part of it, you take smaller and smaller parts forever, eventually you have, after forever, whatever that means, you have 0. And so there we go. That's the long run behavior.
I have a question.
Question.
So the infinite, so it's infinite, the power is infinite, but it eventually will go to 0. So there potentially could be a number up there in that if you were to like calculate it out. Does that make sense?
Well, yeah, that's a good question. So the trick is we can't do something forever.
Yeah.
So if you stop after 10 million times, there'll still be something left. But this says go forever. So if you go forever, there's nothing. See the difference? This is trippy, isn't it? This is calculus goes here. So the trick is it's not just 10 million times, it's forever. So if you take a smaller and smaller part, 1/5, 1/5, 1/5, which is smaller and smaller part, ... forever, it will be 0. There'll be nothing left. If you stop at any point in time, yeah, there's still something left. But this says, don't stop till forever is over. You think, well, how can you do that? Can't do it, but we can think about it. So it's exactly equal to 0. After forever, think about the craziness of that statement I just made. After forever, it's exactly 0.
Makes sense.
There it is. Good question.